Good morning, geometry. This video that we're about ready to do is volume of two base figures. It would be volume of prisms, volumes of cylinders, anything where you have one bottom and another bottom, two bases, and those two bases are the same. Could be two bases tipped over on its side, but it's two bases, and then the figure is consistent between those two bases. So we're going to do some volume formulas. What you should do with me, I'm going to go kind of fast, so pause it where you need to. You're going to draw it, you're going to label it, you're going to find the volume. So here we are on the first one. You should press pause. You should draw this figure. You should label it rectangular prism, and we're going to find volume. Okay, all two base figures have one formula. Volume is equal to big B times H. And big B stands for area of the base. And the H, so that big B right there, that's area of the base. How big is the base? And it is, we labeled as big B because that denotes area of the base. And then the H is height of prism. Height of whatever, height of object. And the height of the object, I'm just going to put in parentheses, it has to be perpendicular to the base. So if it's not stated, we're going to assume that the figure is a right object, a right prism, a right cylinder. We can still use oblique formulas for some other ones, but for right now we're gonna be dealing with right. So here we have a rectangular prism. We're going to put volume is equal to big BH. And what we're going to have to do is we're going to have to go in and fill in a formula for big B, stands for area of the base. So here I look at it. I have a base down here and I have a base up here. So base is a rectangle. So big B for a rectangle is base times height. And then that H right there. Now you see two heights. One is height of the base rectangle, one is height of the prism. So if I'm going to do this, I'm going to say this right here, area of the base, is 6 times 4. And then the height of the object is 20. You should have a calculator. Do these calculations with me. 6 times 4 times 20. 6 times 4 times 20. And I got 480. 480. And there is no label on mine, so I'm just going to put units cubed. Measures of volume are how much could we put inside something. If there was a little hole in the top here, or if that was an open box on the top, how many cubic units could I put in there? How many little cubes could I fill this thing up with? 480 cubic units. Okay, probably the hardest one. Octagonal prism. The base is an octagon, and it is a prism. It has two bases. It has a base down here, and it has a base up here. I'm going to put volume equals big BH. Okay? And I can already fill in the 38, whatever big B is, and then the height I already know is 38. But the hard part about this one, I need to go in and I need to find the area of the base. So I'm going to draw that triangle that we talked about before. There's the triangle. And if I found the area of that triangle, that's be like a triangle down here. If I found the area of that triangle, I could count how many triangles I have. Well, there's 8 triangles, and then I could find the area of the base. So let's go in here. This is 16. I'm going to find this angle with n minus 2 times 180 over n, and my n value is 8. I'm going to do a little bit of the math in my head. 8 minus 2 is 6. So it's 6 times 180 all over the number of sides, which is 8. I'm going to do that. 6 times 180 divided by 8. And that's 135 degrees. So this whole angle right there is 135. And I'm going to divide that by 2 because I'm going to need that for my trig calculations. This angle right here is 67.5 degrees. Okay? What I really need to find the area of that triangle is I need the height of that triangle. So I'm going to put a couple things on here. I'm going to use a different color here. Okay, so I know this is 67.5. Well, this little chunk here is half, so that's 8. And I don't know the height. I'm going to call it H. And what I'd like you to do is pause it and see if you can figure out the height with a trig formula. Okay, here we go. We're going to take the opposite and adjacent. We're going to take the tangent. The tangent of 67.5. Tangent is equal to TOA, opposite over adjacent, so h over 8. And I can put that over 1, and I can crank through on my calculators. You should be doing this with me. The tangent of 67.5 times 8. And what I got is I got 180.7. Ooh, that sounds kind of big. Am I in the right mode? Nope, I got to redo it. My bad. I was in the wrong mode on my calculator. That sounded too big. Let's try this again. The tangent of 67.5 times 8. I got 19.3. That's better. H is 19.3. Now what I can do is I can find the area of that base triangle there, which will give me the area of the base, which I can plug in and find my total area. All right, so let's find the area of the triangle. Area of the triangle base. Well, I'm going to do 1/2 the base, which is 16, and then the height, which is that 19.3. And I did leave that on my calculator because I want to use that big long decimal in my calculation. I don't want to just get rid of that decimal. So I'm going to leave that decimal on here. So I'll do a little bit of easy math. Half of 16 is 8. So if I take 19.3 times 8, I'll get 154.5. 154.5. That is not what goes there. That's the area of one triangle. There's 8 sides. So there's 1, 2, 3, 4, 5, 6, 7, 8 triangles. I'm going to multiply that number times 8. And I got 1236.1. Come on. 1236.08. 08. And that's what goes in for the area of the base. 1236.08. I'll multiply that by 38, and I'll get 46970.94. And this one's in feet, so I'm going to put feet cubed, which is really kind of big. I mean, we're talking about a 38-foot. Maybe this is an old school barn by 16. How many foot by foot hay bales could we put in that weird shaped barn? Well, 46,970.94 hay bales if they were all 1 cubic foot. So these numbers can get big. Volume can get very big. All right, next one. A cylinder. Now on the cylinder one, I've seen it on the ACT all the time, so I'm going to do this one in a little bit of a unique way. We're going to get the exact answer, the pi answer, and then after we get the pi answer out, we'll go ahead and crank up the decimal. But volume of a 2 base figure, and it's still 2 base because I got a base down there and I got a base up there, and it's consistent all the way up. So I'm going to put big BH. But I got to find the area of the base, and the base is this whole big circle, and I know the area of the base is a circle is pi r squared, and then I still have my height, which is 20. And this is actually pretty easy to do for an exact answer. A lot of times you can get this without a calculator. So that's 22. I'll square 22 on my calculator, but it's pi, and then the radius of that thing is 22 squared, and then the height is 20. And if I wanted the exact answer, I would leave the pi out of it, and I would do 22 squared times 20. 22 squared times 20. And I got 9,680. 9,680 pi cubic centimeters, centimeters cubed. And that, I see that all the time on the ACT. Find the volume of the right cylinder is what they would say. And they might even give you this formula. And looking for an exact answer would be the one with pi in it. So we have that pi answer now, or that exact with pi in there. And I'm going to multiply that by pi, and I'm going to go ahead and find the decimal right now. 30,410. 30,410.62 cubic centimeters. And I do think both answers have merit. They are both good. That's a comma there. 30,410. both answers have merit. You have your exact pi answer, you have your decimal approximation. So be ready to be able to find both. Next one. The volume of a cylinder is 980 pi. The height of the cylinder is 20 inches. What is the radius of the cylinder? The next couple questions are questions directly off of your Canvas quiz. So take these down, pay extra attention to these. So volume, big B times H. And this time it tells me my volume is 980 pi. I'm going to plug that in for B, 980 pi. Big B, area of the base. It says, what is the radius of the cylinder? We should draw this picture. That should be part of what we do. So there's my cylinder right there. Okay. And it tells me the height of the cylinder is 20. It wants to know the radius. That's my R. That's my value that I don't know. But I do know that big B for a cylinder is the area of the base. Big B is pi r squared. And then I still have my H. Well, what I can do is I can plug the 20 in for the H. And now I can go in and I can find that R value. It's going to take some algebra though. So I'm going to divide by both the 20 and the pi. Divide by 20 pi. Pi's wipe out, 20's wipe out, and I'm left with r squared. Make sure you have the little squared there. That's important. And here the pi's a wipe out, and well, I can do this math in my head here too, because the zeros are going to cancel each other out, and 98 over 2 is 49. So if I square root, I get r is plus or minus 7, but it's geometry class, so we only take the positive value. The radius of a cylinder could not be negative 7. So my radius is going to be, well, this is inches in inches, so my radius is 7 inches. And we have it. Okay, next one, an oblique cylinder has a height. Now, what oblique means is instead of straight up and down, it's funky, it's over on the side. And I do have a picture of an oblique cylinder here, if I can find it. Hold on. Oh, yeah, there's my oblique cylinder. Here's an oblique cylinder. Okay, it is kind of funky. It is kicked over. This is no ordinary person you're dealing with here, because that's oblique. But the Cavaliere's principle, if you looked in the book, says even if it's oblique, even if it's kicked over on its side like this, the volume is exactly the same. We use exactly the same formula. It is no different. So we're going to go ahead and we're going to draw a picture of this first. So an oblique cylinder has a height of 5 and a diameter of 4. So I'm going to draw the bottom, the diameter of 4 centimeters, and a height of 5 centimeters. Well, it's oblique like this, so it's kind of over, and I'm going to draw the top. And this one says straight up the height. So that straight up height would be this little kicker right in here. And that's good, because I mean that's what we need for this. Height of 5 centimeters. Okay? And if you're doing oblique, that's what you got to use. Now, some problems, let's just talk about it. Some problems will give me this chunk, and they won't give me the height. And if they gave you this and this, well, it'd be a Pythagorean theorem problem. You'd do a squared plus b squared equals c squared, and you could go in and you could find the height. That's not the case on this one. This one just straight up gives me the height. So I'm going to say volume of this thing is equal to big BH. Big B stands for the area of the base. Here's the base. Base of a circle is pi r squared times whatever the height is. So it's pi, well, my radius is 2. So pi 2 squared, and it tells me the height is 5. So 4, 2 times 2 is 4, times 5 is 20. It's exactly 20 pi cubic centimeters. Let's go ahead and do 20 pi on our calculators. 62.83, approximately 62.83 cubic centimeters is what I got. Volume of the oblique cylinder. All right, the last one for today. I did a composite figure. A composite figure here is one where it has multiple pieces. And just like when you had a composite figure for area, you chunked it up into things that you know. You're going to do the same thing. You're going to chunk it up into pieces that you know. And really what we have here is we have this prism on the bottom. Forget about the top. Forget about the roof for a second. You have this prism on the bottom, and then you have half of a cylinder on the top. It's like somebody took a cylinder, they chopped it off, and they plopped it down right on top of that, looks like, well, 8 by 6 square prism. So I'm going to treat it that way. The total volume of this thing is going to be the bottom prism plus the top half of a cylinder. Okay? So let's go through the formula. Prism, big BH. 1/2 of a cylinder is also big BH. Okay? All right, let's take the prism, the area of the base. Now, really what we have is we have this figure. It's a 2-base figure, like this. There's 2 bases, but it went kind of over on its side like that, see? It's not straight up and down, but the bases are still these front and back bases. I guess you could count the base down here because it's the same here, but I'm gonna say these are the 2 bases of the half of the cylinder, so I'm also gonna say these are the 2 bases of the square pyramid. There would be other ways of doing this one, but I'm gonna go ahead with base and height. So area of the base is 8 times 6. Area of the base, 8 times 6, that being the base, and the height of the object is 10. 8 times 6 is 48 times 10. I'm going to make sure, I think it's 480. 8 times 6 times 10 is 480. So just the bottom part is 480. And then I'm going to take half of a cylinder. Well, let's look at this thing. So cylinder, we need the radius. If that's 8, that's 4. And the area of the base for this thing is pi r squared times how tall it is, times the h. So take 1/2 of pi and 4 squared. And the height, the height of this cylinder, again, it's not a cylinder that's up, it's one that went boom and then got cut in half. But this distance is still the height, which is 10. So I'll put a 10 there. Well, 4 squared is 16 times 10 is 160. Then I got to take half of that 160. 16 times 10 is 160. Half of 160 is 80, and then I still have a pi left over. So just doing the math in my head, it's 80 pi right here. And if you're on the ACT, it would tell you 480 plus 80 pi is the volume of this figure. Of course, we're going to also find the decimal, 480 plus 80 pi, and I got 731.3. 731.3, and it doesn't give us a unit, so we'll just put units cubed. Units cubed. All right, and I think that's it. Yep. That is the end of 2-base volume formulas. Should be able to do all your homework now and go from there. Good luck.